So my goal for this lesson is that you guys will be able to find square roots and classify and order real numbers. So we're going to start off by talking about square roots. A square root is just one of two equal factors of a number. For example, if you have 64, we know that 64 is the same as 8 times 8. So what I always ask myself is, what number can I multiply by itself to give me this number here under the square root symbol? And that would be 8. So the square root of 64 is equal to 8. Okay, this symbol is called a radical symbol. This part right here. This is the radical symbol, and what's under here is called the radicand. So in this example, 64 is my radicand. So when I simplify it, I get the answer as 8. So the square root of 64 is equal to 8. There's a nice thing that we can do with square roots. When you have the square root of a number divided by another number, you can break it up into two square roots. So I could rewrite this as the square root of 59 divided by the square root of 56. So once again, I want to ask myself, what number can I multiply by itself that's going to give me 49? What number times itself is equal to 49? Well, the answer is 7. 7 times 7 is equal to 49. So I know the square root then of 49 is equal to 7. Okay, what number can I multiply by itself to give me 256? That is 16. 16 times 16 is equal to 256. So the square root of 256 is 16. So I can simplify the square root of 49 divided by 256 as just 7 over 16. On this one we have plus or minus the square root of 16 over 9. Notice there's not a minus sign in here. We can't have that. You cannot have a minus inside of the square root because the result is an unreal number. It's an imaginary number. We don't want imaginary numbers for our purposes. So what I want to do is I want to split this up into two things like I did on the first one. So it's equal to the positive or minus square root of 16 over the square root of 9. Now this one you might know a little better than you did the 256. What number times itself is equal to 16? 4 times 4 is equal to 16. So I've got the square root of 4 times 4 over the square root of what number times itself gives me 9? Well, we know that's 3 times 3. So when I simplify this, I get, I don't want to forget my plus or minus not square root, we're done with that. We're taking it outside the square root, so we have 4 over 3. Plus or minus 4 over 3. This indicates both square roots, because if you think about it, if I have negative 4 squared, that gives me a positive 16 because it's a negative times a negative. We know from our song a negative times a negative is a positive. It says multiply or divide. It's an easy thought. Both signs are positive. Different signs are not. Or same sign is positive, I guess is what it says. But same sign. So I've got a negative times a negative. Same thing is true if I just have 4 squared. 4 times 4, same sign, is going to be a positive 16. Different sides are not. So that's what this plus or minus is indicating, that it's both square roots. It's the negative square root and it's the positive square root. Okay, so if I look at plus or minus the square root of 0.81. Now, I know a lot of people look at that and let the decimal point totally throw them off. But if we just ignore that for just a second and think about the square root of 81, what number times itself is going to give me 81? Well, we know that that's 9 times 9. 9 times 9 is 81. Well, now let's go back and consider this decimal. Okay? I need something that's going to give me that 0.81. Well, we know that 9 times 9 gives me 81, so using that same concept, I know that when I multiply two decimals, that I have to, or it has one decimal place, then my answer is going to be out two decimal places. So 0.9 times 0.9 is going to give me 0.81. I have to move my decimal place over two places. 9 times 9 is 81, and since there's a number here after the decimal, a number here after the decimal, I have to move this decimal over two places. So the square root of 0.81 is just equal to 0.9. Now, I can't forget this was plus or minus, so I need to keep my plus or minus here in my answer. So the square root of 0.81 is plus or minus 0.9. Okay, let's look at this problem. We've talked a little bit about radicals and graphing inequalities. So what I want to do is look at the completeness property. The completeness property tells us that each point on the number line corresponds to exactly one real number. So if I put a point here, that would correspond to -3. That's an exact location. What I want to do is I want to look at all of the values of x that are larger than or bigger than -2. If you think back to when we did inequalities before, since it's not equal to -2, I want to put an open circle on the -2. So I'm showing all of the numbers bigger than -2, but not equal to -2. Now, some people will think, okay, so why wouldn't I just jump up here and put a circle here on -1, since I know that -1 is bigger than -2? And the reason is because if you just start over here at the -1, you're not taking into consideration -1.5, -1.8, -1.9, all of those decimal numbers in between -2 and -1. So that's why we want to put an open circle here on -2, so we're showing it doesn't include -2, but it's all of the numbers from -2 on up. So that would include that -1.99999 repeating. That's right here, as close to -2 as I can get, but not on it. So we want to start it at -2 and go all the way up. Okay, let's look at another one. A is less than or equal to 4.5. So we know that 4.5 is right here in the middle between 4 and 5. And this time it says that it's equal to. So I'm going to put a closed circle to show that I'm including this point. I'm starting at 4.5, including 4.5, but I want all the A's that are smaller than it. So all of the numbers that are smaller. To check myself, I can look. Okay, I'm pointing my arrow over here. 0 is covered by the way my arrow is going. So let's plug in a 0. Is 0 less than or equal to 4.5? Yeah, so that works. We know that we did it correctly. We put our arrow in the correct direction. My arrow's not covering these numbers over here, which is good because if I put in 5, is 5 less than 4.5 or equal to 4.5? No, so we don't want to point our arrow in this direction because this isn't true. We want to point our arrow in the direction of all of the numbers that make this inequality true. Okay, now let's look at some rational approximations. A rational approximation of an irrational number is a number that is really, really close to, but not equal to, the value of an irrational number. So it's close, but it's not, it'll never be equal to. We're rounding is basically what we're doing. Okay, so if I look at the square root of 19, do you know what the square root of 19 is? Probably not right off the top of your head. You know that it's got to be somewhere between 4 and 5 because we know the square root of 16 is 4. I know the square root of 25 is 5. So the square root of 19 has to be somewhere in between those two numbers. So what I would do is I just go ahead and type it in the calculator. See what the calculator tells me the square root of 19 is. Let me get my calculator out here. I don't know it right off the top of my head. Like I said, I know it's in between 4 and 5. Well, really, I don't even need to go any further. If I'm trying to decide, should it be greater than, less than, or equal to? So if I know that 19 is the square root of 19 is bigger than 4, but less than 5, just the fact that it's bigger than 4 lets me know that what inequality symbol should go in between here. It's going to be greater than, because if this is bigger than 4, well, we already know this is less than 4, so this is going to be bigger. The square root of 19 is going to be greater than the square root of 3.8 repeating. And if I type it in the calculator, I'll go ahead and do that. The square root of 19 is 4.358898944, and it keeps on going. We would have to make a rational approximation. We would just say maybe 4.4. So, of course, 4.4 is bigger than 3.8. Okay, the square root of 196. Hopefully you're familiar with this, but maybe not. So you could type it in your calculator. The square root of 196 is actually 14. So what symbol is going to go in between here? Greater than, less than, or equal to? Well, of course it's going to be equal to, because we know that 14 is equal to the square root of 196, which is also 14. Okay, square root of 48 and 6.9, this symbol means on top of the 9 that it is repeating, 6.9999999. Okay, the square root of 48, I don't know what that is. I know the square root of 49 is 7, so this has to be less than 7, but that doesn't really help me because this is also less than 7. So what I want to do is I'm going to type it in my calculator. Square root of 48 is equal to 6.92820323. I'm going to make an approximation, a rational approximation, and do 6.928. I'll go ahead and take it out 3 places. Okay, well, we know this is 6.9 repeating, so it's 6.999, and it just keeps on going. So which one's bigger? Well, of course, the 6.9 repeating is larger than the square root of 48. So we have the square root of 48 is less than 6.9 repeating. Okay, last thing I want to talk about is ordering real numbers, putting them in order. So if I have 2.63 repeating, I have the negative square root of 7, and I have 8 over 3, and I have 53 over negative 20. Okay, I want to order these from least to greatest. Least to greatest. Well, this is kind of hard because these are all in different formats. You know, this one's a decimal, this one's a square root, then I've got fractions. So what I would like to do is write them all as the same. Either write them all as a fraction, write them all as a decimal. And it's a whole lot easier to write them all as a decimal. So that's what I'm going to do. I've got 2.63 repeating. It's already a decimal. The square root, the negative square root of 7, I'm just going to type that in my calculator if you don't know that already, and I don't, I wouldn't imagine that you would, is negative 2.645, so we're just going to round it to 2.646. I'm making, use my vocabulary here, a rational approximation. Okay, 8 over 3 is equal to, once again, we can just divide this out. It's 2.6 repeating. And 53 over negative 20. We know that different signs, when I divide, so it's going to be a negative. Same signs are positive, different signs are not. So since it's not positive, it's got to be negative. So negative 2.65. So now it's going to be a whole lot easier to list these least to greatest. Which one is the smallest? Well, if I look at this, the very smallest one is this one right here. In its original form, it was 53 over 20. So that's what I want to put, 53 over negative 20. This is smaller than, so I'm done with it. What would come next? Next would be my, I was confusing myself here, 2.6 repeating. This one's positive. This one is negative. So, of course, the negative is going to come next. So, it's going to be the negative square root of 7, which is less than, okay, which of these are smaller, 2.63 or 2.6 repeating? That would be the 2.63. And then next, I've got the 8/3, less than 8/3, which is equal to 2.6 repeating. So now I have listed my numbers here from least to greatest. 53 over negative 20 is less than the negative square root of 7, which is less than 2.63 repeating, which is less than 8 over 3. Okay, that takes care of our notes for today. Please check Progress Book to get your homework assignment.